Today I am going to explain the cross product of two vectors, which is also known as the vector product of two vectors. So let's start. Cross product or vector product of two non-zero vectors, which is denoted by vector A cross vector B, is defined as follows. Vector A cross vector B is equal to magnitude of vector A into magnitude of vector B sine theta n cap, where theta is the angle between the vector A and B and n cap is the unit vector which is perpendicular to both vector A and vector B. So we can say that if A vector cross B vector is equal to C vector, then magnitude of C vector is equal to magnitude of A vector into magnitude of B vector sine theta, because this part of the cross product is scalar and this is the magnitude of this cross product. So magnitude of C vector is magnitude of A vector into magnitude of B vector sine theta, and C vector is perpendicular to both vector A and vector B. If diagrammatically we represent this concept, so this is A vector and this is B vector and theta is the angle between them, then the cross product of two vectors A cross B, which is denoted by C here in this case, is perpendicular to both the vectors vector A and vector B. And since it is a three-dimensional concept and it is impossible to depict a three-dimensional concept on a two-dimensional plane, so we need to imagine this vector, which is cross product of two vectors in the space like this. This is cross product of A vector and B vector, and this is perpendicular to A and perpendicular to B both. Now in this section we'll discuss some very important corollary inferred by the cross product of two vectors. So the corollary number one: since A vector cross B vector is equal to magnitude of A vector into magnitude of B vector sine theta n cap, where n cap is a unit vector which is perpendicular to both A and B, by the definition we know that. But if A vector is parallel to B vector, that means the angle between them, that is theta, is equal to 0, and for 0 degree sine theta is equal to 0. So if we substitute sine theta is equal to 0 in this result, we have A vector cross B vector is equal to 0 vector. So we concluded that the cross product of two vectors is always a 0 vector if the vectors are parallel to each other. Now this is corollary number 2. Since for all vector A is parallel to vector A, because every vector is parallel to itself, then from the corollary number 1, vector A cross vector A is equal to a 0 vector. Now corollary number 3: since I cap is parallel to I cap and J cap is parallel to J cap and K cap is parallel to K cap, so from the corollary number 2 we get I cap cross I cap is equal to J cap cross J cap is equal to K cap cross K cap, all are equal to 0 vector. Corollary number 4: if A vector is perpendicular to B vector, then theta, that is the angle between them, must be pi by 2 or 90 degree. It implies that sine theta is equal to 1. Thus vector A cross vector B is equal to magnitude of vector A into magnitude of vector B n cap, because sine theta is equal to 1 Now since I cap and j cap, I cap is perpendicular to j cap, so I cap cross j cap by the definition is equal to magnitude of I cap and into magnitude of j cap into sine theta, which is equal to 1 in the case of perpendicularity. So only n cap is left, and we have n cap only because the magnitude of I cap and j cap both is equal to unity. Since n cap is a unit vector and it is perpendicular to both the vectors I cap and j cap, as we know that by the definition, the cross product of two vectors is perpendicular to both of them. So n cap is such a unit vector which is perpendicular to both of them. Hence we may conclude that n cap is equal to k cap, because k cap is a unit vector along z axis which is perpendicular to both the unit vectors I cap and j cap. So we infer from this that I cap cross j cap is equal to k cap. Similarly, we may conclude that j cap cross k cap is equal to I cap and k cap cross I cap is equal to j cap. Now remember, A cross B is equal to minus B cross A. So it implies that if I cap cross j cap is equal to k cap, then in the reverse sequence of this, j cap cross I cap is equal to minus k cap by this property. J cap cross k cap is equal to I cap, then k cap cross j cap is equal to minus I cap, and similarly k cap cross I cap is equal to j cap, then I cap cross k cap is equal to minus j cap. How to remember this? To remember this, you will have to draw I cap, j cap, k cap two times, mark arrows in one diagram, mark arrows in counterclockwise direction, and in the other one in the clockwise direction. So if the sequence of I cap, j cap, k cap is in counterclockwise direction, the result is positive, and if the sequence of I cap, j cap, k cap is in clockwise direction, its product is negative. Now corollary number 5, which is also very important corollary. Say area of triangle ABC is equal to half base into height AL. So half BC into AL, because BC is the base of the triangle and AL is height of the triangle. So since in this triangle ALB, because this is right angle triangle, so AL upon AB or BA, AL upon BA is equal to sine theta, because this is perpendicular upon hypotenuse and the angle B is equal to theta. So AL upon BA is equal to sine theta. So transposing BA to right hand side, we have AL is equal to BA sine theta. So area of triangle ABC is equal to half BC into BA sine theta, because we have replaced the value of AL as BA sine theta here in this formula. So we have area of triangle ABC is equal to half BC into BA sine theta. Since we know that BC means the length of the side BC, and BC side of the triangle is represented in magnitude and direction by vector A, then the length of the side BC is equal to the magnitude of vector A. Similarly, the side BA of the triangle is represented in magnitude and direction by vector B. So BA, that is the length of BA is equal to the magnitude of vector B. So if we replace BC by magnitude of vector A and BA by magnitude of vector B, in this formula we have area of triangle ABC is equal to half magnitude of vector A into magnitude of vector B sine theta, which is numerically equal to half magnitude of vector A cross vector B, since magnitude of vector A into vector B is equal to the magnitude of or modulus of magnitude of vector A into magnitude of vector B sine theta n cap, and magnitude of sine theta is equal to sine theta, since theta is an acute angle less than 90, so sine theta is positive, so magnitude of sine theta can be written as only sine theta. So magnitude of A and into magnitude of B vector sine theta, and magnitude of n cap is 1 because this is unit vector, so simply magnitude of vector A cross vector B is equal to magnitude of vector A into magnitude of vector B sine theta. So we may replace this expression, that is magnitude of vector A into magnitude of vector B sine theta, by magnitude of A cross B. So we come to the conclusion that if two sides of a triangle are represented by two vectors, vector A and vector B, in magnitude and direction, then the area of the triangle is equal to half magnitude of vector A and vector B. So this is very important corollary inferred by cross product of two vectors.